In this video, we're going to discuss topic 5.3, so which is going to be a graph. So first, we're going to have a look at graph of sine, so which is going to be in the form of a sine bx minus c plus d. And then we're also going to discuss graph of cosines, which is also in the form of a cos of bx minus c plus d. So this whole alphabet a, b, c, and d. So each of them are going to give a certain characteristic for the sine and cosine graph. So that's what we're going to have a look at later. So first we're going to have a look at how do we sketch the graph. So if we have different values of a, b, c, and d, and then we're going to have a look at that if you're given a graph. So how do you actually convert that to be in terms of a sine and cos equation? All right, and of course in the next topic, so we're going to talk about the graph of tangent. So now let's focus for graph of sine and cosine in this 5.3 topic. So what happened is that it says over here the graph of y equal a sine x. So what happened is that first, before I put together everything which involve a, b, c, and d, I'm going to show it to you bit by bit. First of all, I'm going to show it to you. So what does the effect of the value of a is going to take on the graph characteristics of the sine and cosine function. So this is over here the graph of y equal a sine x and y equal a cos x, where a is not equal 0, and this is actually should be in capital. So instead of a, it should be a, capital A is not equal 0. So we'll have the same shape as the graph of y equal sine x or y equal cos of x respectively, except with range from negative a until a, and the amplitude is going to be a. Right, so basically negative a is going to be the minimum value of the graph, and a is going to be the maximum value of the graph. And of course, for this case, if you have y equals sine x, so this actually means that your value of a is equal 1, and for the case of y equal cos of x, it's the same idea. So the value of a is actually going to equal 1. Okay, let's recall first. So how does graph of sine x and cos x looks like? So if you remember, I've shown this to you during the previous topic, but now let's have a look at it again. So here first, so I'm going to sketch a graph of y equal a sine x, and then on the other side I'm going to sketch a graph of a, so let's not make it a, but let's make it a simple graph of y equal sine x, and on the other side I'm going to sketch a graph of y equal cos of x, just to refresh the idea for you. Okay, so basically this is going to be my axis, right? So here this is going to be y and this is going to be x, and if this is actually t, so this is going to be t as well. So basically this is going to determine the vertical axis. So what is the vertical axis? So this over here is called as the vertical axis. Sometimes we use y, sometimes we use f of x, and so on. Okay, and whatever variable that we have on the right hand side is going to determine our horizontal axis. So this is our horizontal axis because we have x on this side, so therefore this is going to be x-axis. If we are using t, then it's going to be the t-axis. Okay, so how does a graph of y equals sine x looks like? So the most basic graph actually looks like this. So this is the idea of graph y equal sine of x. So there are important points that we have to capture. First is going to be 0, and in the middle over here, so this is going to be a value of pi, and it's going to end at a value of x equal to pi. And of course, in the middle over here, this is going to be between 0 and pi, that's pi over 2, and between pi and pi over 2, so that is between pi and 2 pi is going to be 3 pi over 2. So when you sketch for sine function, so these are going to be the 5 important points that you have to capture in the graph. So we don't really care about the other bits of the graph, but those 5, they are the most important ones. Okay, so that will be pretty much the same idea when you have y equal cos of x. So there are also 5 important points so that we have to capture on the graph. So for the case of cos of x, so it's going to look like this. Okay, so that's how the graph looks like. And the same idea, so this is going to be from 0 until 2 pi, and of course in the middle over here is going to be pi, so where we have a minimum value. So this is going to be 0, and in between 0 and pi, so which is going to be right there. This is going to be a value of pi over 2, and between pi and 2 pi, that is going to be a value of 3 pi over 2. So the 5 points that you have to capture is going to be the maximum, which is at 0, and this point here, and this is going to be the last one. Okay, this thing is that, so for this case, so what happened is that, what is my a value? So my a value is actually equal 1. So a is equal 1. So when we write y cosine x or y equal cos x, basically the value of a is going to equal 1. And for this case, what happened is that the a is going to determine the maximum and the minimum value. So when you have a value of 1, so right away what happened is that, so the maximum value here is going to be 1, and the minimum value is going to be negative of 1. So the same goes for this one, because when your a value is equal 1, automatically the maximum value is going to be 1, the minimum value is going to be negative of 1. So that is how the value of a is going to influence your graph. So it's going to determine the maximum and also the minimum value. So one is going to be positive of a, so the other one is going to be negative of a. So now let's have a look at the graph over here. So I have two graphs, so which I plot on the same axis. So here what happened is that I have graph of y equal 1 sine x, which is the one that we have over here. So what happened here is that my a value is equal 1, and the one in pink is actually graph of y equal 2 sine x, for which for this case my a value is going to equal 2. So if you notice, so the shape is basically exactly the same. So both actually start at 0 and end at 2 pi. So the shape is basically the same, but only the height of the maximum and the minimum is different. So what happened is that, so for the case of y equals sine of x, so this one right here, our minimum value is going to be at 1 and also negative 1. Maximum value is 1, minimum value is negative 1. And for the case of the pink function, y equal 2 sine of x, because now my amplitude value is equal to 2, so the maximum value is going to be at 2 and the minimum value is going to be at negative of 2. So that will be the same idea for the case of cosine as well, for which the pink graph is actually half of sine cos x. So here my a value is equal a half, so which tells us why the maximum value is actually a half and the minimum value is negative a half. And for the case of y equal cos x, so this is actually y equal 1 cos x. And from here we can tell right away that a value is going to equal 1, so maximum value is going to be at 1 and minimum value is going to be at negative of 1. So basically, so the sine and cos graph is still going to have the same shape. So it's still going to be from a period, one period is still going to be from 0 until 2 pi. So it's going to be from 0 until 2 pi, but the only difference will be only in terms of the height. So the amplitude is going to determine the height of your graph. So what is going to be the minimum and what is going to be the maximum value. Okay, so now, so the graph says over here, graph each function over the interval from negative 2 pi to 2 pi. So now I'm going to sketch a graph of y equal 2 cos of x and y equal 2 over 3 sine of x. So now let's sketch both of them. Okay, so now I'm going to have first, it's going to be y equal to cos of x. So let me draw the axis first. So actually when we have a trigonometric graph, so it doesn't actually just stop until here. It doesn't just stop until there, but it actually repeats it. But most of the time you're only going to draw one period, and we know that one period is going to be from 0 until 2 pi. But actually it's actually going to be continuous, having the same shape over and over again. But we only, for the sake of sketching, for the sake of like looking at how the graph looks like, we are only going to sketch only one period, which is going to be from 0 to 2 pi. So depending on the function itself. Okay, so that is going to be my axis. So of course here I'm using y on the left hand side, x on the right hand side. So those are going to be my axis. And now this is going to be a cos function. So we know that the cos function looks like this. And then we're going to put the values. So it starts from 0 and it's going to end at 2 pi. So the middle here is going to be pi. And then I'm going to have pi over 2 in between. And also 3 pi over 2 at this point. Okay, so those are going to be the value that I have to capture. And then the only difference will be, so the fact that my a value, so for this case what happened is that, so the a value is going to equal 2. So therefore my maximum value is going to be a value of 2, so which is going to be right here, and the minimum value, which is going to be somewhere over here, so this is going to be negative of 2. So that is going to be a graph of y equal 2 cos of x. So now let me proceed to the second example. For the second example, I'm going to have a sine graph. So that's a graph of y equal to 2 over 3, so sine of x. So it will be exactly the same idea. But for this case, what happened is that my amplitude is going to be a value of 2 over 3. So this is my a value. So my a value, that's going to equal 2 over 3. Okay, how does a graph of sine looks like? Let me put the axis first. So the graph of sine look like this. I'm going to have two curves, one up and one down. So it's going to extend from 0 until 2 pi. So that's one period. And then in the middle, this is going to be a value of pi. Somewhere over here, it's going to be pi over 2. And in the middle between pi and 2 pi is going to be 3 pi over 2. So those are going to be the only 5 points that you have to capture on your graph. And of course, for this case, the maximum value is going to be at 2 over 3. And the minimum value is going to be at negative 2 over 3. So that is what the value of a, how the value of a affected your graph. So it's just going to affect the minimum and also the maximum value. So that's for A. Okay, now let's have a look at B. So what does the value of B does? So for B greater than 0, so it's being told here, so B greater than 0. So B always have to be a value that is greater than 0. So the graph of y equal a sine bx will resemble that of y equal a sine x. So meaning that y equal a sine bx is going to equal a sine x. The shape is going to be pretty much the same, but with a period of 2 pi over b. So what happened is that when you have graph of a sine x, so the period is going to equal 2 pi. So your graph is going to be from 0 until 2 pi. So that is what happened when you sketch. But when you have a function of y equal a sine bx, so now you're going to have a new period value. And what is going to be the new period value? So it's going to be given by 2 pi over b. So you have to identify what is going to be the value of b from your equation. So put it into the formula. So this is sort of a formula. And you're going to find the value of the period. So basically the period is telling you where to stop. So when the period is equal to pi, so it's going to be from 0 until 2 pi. So if the period value is equal pi, so let's put over here. So let's say if I say that, oh, the period is going to be a pi value. So therefore your graph is going to extend from 0 until pi. So it's telling you, so where does the graph stops? So how does one period looks like? So how much distance does it cover on the x-axis? Okay, so this is going to be the first example. So it's a cos function. So I don't know what happened, that the axis is actually in the middle right there. It should be up here, and this is going to be our x. So it's going to be a function of y equal cos of 2x. So here there's two things that you should be able to identify. That first, the value of a, that is going to equal 1. So that is the first thing that you should identify. And then I forgot to tell you just now, so how do we identify the value of b? So the value of b is going to be the value that is right next to the independent variable. So if you're using x, so it's going to be right next to x. So if you're using t, it's going to be right next to t, and so on. So whatever variable that we had on the right hand side, so the number right next to that, so that is going to be your b value. And for this case, of course, we can identify that the b value is going to equal 2. So that's my value right next to x. So it's a value of 2. So according to the formula, so the period is given by 2 pi over b. Now that we have identified that the value of b is equal to 2, so the formula is going to be 2 pi over 2, so that is going to equal pi. So meaning that previously, so instead of a graph from 0 until 2 pi, so now our graph is going to be from 0 until pi. So that is where it should stop. So if you notice right here, what happened is that this is going to be 0. And the curve, so remember the cos always have a curve that looks like this. But now, instead of like stopping at 2 pi, so this curve over here actually stop at pi, because that is the period value. One period is going to be from 0 until pi. So that is what the value actually tells you. And of course, like the middle between 0 and pi is going to be pi over 2. And the value which is going to be in between them, So here this is going to be pi over 4, right? So in between 0 and pi over 2, and between pi and pi over 2, so this is going to be a value of 3 pi over 4. Okay, so those are going to be the values that we have to capture on our function. And of course, because a is a value of 1, so maximum value is going to be at 1, and the minimum value is going to be at negative of 1. Okay, so this is actually two graphs being put together. One is a graph of y equal cos of x, so which is actually in red. So let me label over here. So the one in red is actually the dotted one. So this is actually the graph of y equal cos of x. And the blue one is of course graph of y equal cos of x. And for this case, for when you have y equal cos of x, the period value is equal to pi, because that is going to be 2 pi over 1, because b value is equal 1. And this one, b value is equal 2. So what happens is that the period is going to equal 2 pi over 2. So that is going to equal pi. So if you notice, remember the shape, of course, this is going to be one period. So that is how one period should looks like. And for the case of the red function, y equal cos of x, so it's going to stop when it covers from 0 until 2 pi. And of course, for the case of y equal cos 2x, so one curve actually is going to be only from 0 until pi. So it's going to stop right there. And of course, from pi until 2 pi, so that is going to be another curve, and so on. So that is how, like, the value of b actually differentiate your graph. So they're going to have a different position where the curve actually stopped. So when you have cos of 2x period pi, it stopped at pi. When the period is 2 pi, it stopped at 2 pi, and so on. So that will be the idea. So let me clean this. So that it will look neater for your notes. Okay. Right, so now let's catch example. So our example is going to be on sine function. So the question says determine the amplitude and the period. So amplitude is going to be the value of a, period will be concerning the value of b, for a function of y equal 3 sine pi over 2t. Then graph the function for negative 4 and for t values from negative 4 until 4. So if you notice, for this case, we are no longer using y and x. The variable that we're using on the right hand side is going to be t. So when you sketch, you're going to have y-axis and also t-axis. First of all, before you start, so identify the value of a and b. For this case, my a value is going to equal 3. And my b value, so that is going to equal pi over 2. Okay, so I'm going to put it over here. So a is equal 3. So what happened is that my maximum value is going to be at 3. And my minimum value, so it's going to be at negative of 3. So that is going to be the first characteristic of the graph that we're going to sketch. The second characteristic will be concerning the b value, so which is the period. So period is given by a formula of 2 pi over b, and for this case is going to be 2 pi over 2. So it's going to be 2 pi multiplied by 2 over pi. So this 2, they're going to cancel each other. So basically my period is going to take a value of 4. So one curve is going to be from 0 until 4. So how does one curve of sine looks like? So if you remember, so one curve of sine looks like this. So you can have a curve at the top and curve at the bottom, then it's going to stop. And this will be from 0 until 4. So that is why. So when I sketch, it's going to look like this. Let me put it in the middle. Okay. So remember, this is going to be y and this is going to be t. So that is the variable that we use. So let me sketch the sine in blue. So that is going to be one curve. And of course, for this case, it's going to be from 0 until 4. And the middle is going to be a value of 2. Here is going to be a value of 1. And here is going to be a value of 3. But however, so it has been specified over here so that your graph should covers from -4 until 4. And remember, when you have a periodic function, so the shape can be repeated, the idea is going to be copy and paste. So basically what I have to do is I have to copy the shape. This is going to be the shape that I'm going to copy, and I'm going to put it on, no, let's not move that. And I'm going to copy the shape and I'm going to move that to the other side. So the idea is copy and paste. So that is why. So when I sketch it from -4 until 4, so it's going to look like this because I copy and paste. It's going to look somehow like that. Okay, and this is going to be from 0 until -4. In the middle is going to be -2. This is going to be -3, and this is going to be -1. Okay, so remember, when you replicate your function, so the idea is copy and paste. So that is going to be how the graph looks like from -4 until 4. So if the question asks you to sketch only from one period, so you only have to sketch this side. Okay, you don't need this side over here. So this is all that you have to sketch. That is one period. But if the question actually specify from where until where, and then you have to copy and paste, put it on the other interval. So that is how we sketch graph with different values of a and b.